Number 5 is the most realistic question of all of them. It has given you actual data that you would have to deal with in the laboratory. When you do this, you're actually going to have to heat this in something, and most of the time that you do this, you're going to heat it in a crucible, and a crucible is just a little dish. So what they are doing is they are giving you the mass of the crucible, which is empty, because again, it's real tough to weigh these things in the actual laboratory unless you have some manner of container. So it's really not hard. All you have to make sure that you do is, if you have the empty mass of the crucible, which is the 12.8 here, and then our second line here is telling you the crucible and the hydrated compound. So the hydrated compound, you're just going to have to subtract the crucible from it so that you can figure out what the hydrated compound is without the container. So if I take my 22.4 grams, which is the crucible and the hydrate, and I subtract out the mass of the crucible, which is 12.80 grams, which is the mass of the crucible, then my hydrate is going to have a mass of 9.6 grams. So it's going to be 9.6 grams of my magnesium sulfate .xH2O without the crucible. All right? Now I'm going to do the exact same thing here, except that after heating it and driving all of the water off, I now have the crucible and the anhydrous compound that is left over, and it apparently weighs 1749. That's here. But again, I don't care about the crucible, so I'm going to have to subtract out the crucible. So I'm going to have to come over here, and I'm going to have to do 1749 grams of the crucible plus the anhydrous compound. And then I'm going to have to subtract out the 1280 grams of the crucible, so that I am left with 4.69 grams of the anhydrous compound, right? So that is the compound without the water. So now I have got my information that now looks like the previous problem. So in the previous problem, I gave you that you had a sample of the hydrated compound and a sample of the anhydrous compound here and here, right? Now you have gotten those numbers. So now you know that you have 9.6 grams of the hydrate and you have 4.69 grams of the anhydrous compound. Now you can do the problem like normal. So this is 9.6 grams of MgSO4.xH2O, and then I'm going to subtractify the 4.69 grams of the anhydrous, which is just the MgSO4, and that is then going to get me 4.91 grams of water. And at this point, I turn them into moles, so this is 1 mole per 18 grams. If I look up all of the mass for magnesium sulfate, I should get about 120.4, assuming I have done my math right. I get 0.0390 moles here, and I get 0.273 moles here. So this is going to be MgSO4 0.0390, and this is going to be water 0.273. So remember, I now divide by the smallest number, and you should end up with a 7-to-1 ratio, assuming I have all my numbers right when I did my math. So the only difference between this problem and the last one is that you have to subtract out the mass of the